Use point plotting to graph the plane curve described by the following parametric equations, and we want to use arrows to show the orientation of the curve. All right, so here we have our parametric equation. You notice x equals t plus 1, y equals the square root of t. You notice that we have two equations here, right? X and y, and also this third variable t, right? That's called the parameter, right? So in order to get these ordered pairs for x and y, right? We're not going to like plug in the value of x and get it for y, right? That's what we used to do before, right? Now we're going to plug in the value of t, and we're going to use t to generate our ordered pairs, okay? So let's make a table, right? So instead of, this is what we normally do, right? We make a table for x and y, and we get our ordered pairs, but now we're going to have this third variable, right? We're going to call that t, and we're going to use t to figure out what these x and y ordered pairs are. Right, notice that there's no restrictions on t, right? So I'm not saying, oh, t has to be bigger than -3 or it has to be less than 7 or anything like that, right? There's no restrictions on t. But actually, if you look at this carefully, it's sort of built in, right? Because of the square root of t. Why is the square root of t? Notice that I can't pick any negative values of t, right? Because negative square roots don't exist. So actually, even though I don't say, hey, t has to be positive, right? Well, mathematically, we just look at this and we assume that, okay, I can only pick positive values of t. So let's go ahead and do that. Round and pick t equals 0, maybe a 1. I mean, I could pick a 2 if I wanted to, okay? But I noticed square root of 2, I mean, we can plot that, I guess. But, you know, let's just plug in some nice perfect squares, right? So 4, maybe 9, maybe 16 or something like that, right? We can do that. So what happens when you plug in 0 in here, right? X is t plus 1, so when you plug into 0, we get 1. Radical 0 is just 0. Right? When you plug in the 1 in here, 1 plus 1 is 2. Radical 1 is 1. When you plug in 2, x equals 2 plus 1, which is 3. Y is going to be radical 2, which we'll just leave that as radical 2, I guess. Right? When we plug in t equals 4, x equals 4 plus 1, which is 5. Radical 4, right? Y is going to be radical 4, which is 2. X, when you plug in 9, 9 plus 1 gives us x equals 10. Y equals radical 9, which is 3. And then we'll just finish up with this last point here. Now, I could pick more points if I wanted to. But hopefully, maybe we can use D6 to get our graph, right? Get a good idea maybe of what our graph will look like, okay? So now I know that I'm not going to pick negative values of, I'm not going to pick negative values of t, which I can see that I don't have any negative values of x or even negative values of y either, right? So I guess we can just go on this side. And we'll just go up here, okay? And I know I'm not going to get any negatives. Okay, let's go ahead and plot these points, right? We got the point 1, comma 0, 2, comma 1. Well, 3... when x is 3, y is radical 2, which is about 1.4, right? So we'll eyeball that about over there. Notice when x is 5, y is 2. Okay? When x is 10, okay, y is 3. And when x is 17, y is 4, right? So, all right, well, what is this the graph of? Well, it's going to be a little bit curved. It's not exactly straight, okay? It's going to be a little bit curved. It's actually a half of a sideways parabola. Okay? So there is our graph. What does it mean about using arrows to show the orientation? So what the arrows do, it goes from smallest value of t to increasing values of t. So what's the smallest value of t here? It's t equals 0, which is this point. Right? So this is t equals 0, this is t equals 1, t equals 2, t equals 3, so on and so forth. So actually, what does that mean? It means that these arrows, right, should be pointing this way. And you notice that there is an arrow at the end, right? I'm not cutting off what values of t we can use. So yes, essentially this will keep going to infinity. So this graph will essentially extend this way.